Good morning, my dear students. Today our lesson is adding and subtracting rational numbers. It is lesson 3 in unit 1. Adding and subtracting rational numbers. Let's start by adding two rational numbers expressed as a over b or fraction a over b. First, when adding two rational numbers having the same denominator, and this is a very easy operation because we will keep the denominator as it is and we will add only the numerator. Let's see. If a over b and c over b are two rational numbers, then a over b plus c over b will be here. I will keep the denominator as it is. Then I will add the numerator a plus c only. Example, 2 over 7 plus 3 over 7 equal 7 as it is. Then 2 plus 3 will be 5 over 7. Another example, 3 over 5 plus negative 1/5. So the denominator as it is, then I will add the numerator. 3 plus negative 1 will be 3 minus 1, which is 2. So the answer will be 2 over 5. Second, adding two rational numbers with different denominators. Okay, how to do this? Also, it is easy. First of all, we will multiply the two denominators together. We will multiply the two denominators together. Then, first numerator will be multiplied by second denominator, and second numerator I will multiply it by the first denominator. Let's see it. A over b and c over d. How to do the addition? I will multiply the two denominators, b multiply d. Then I will multiply first numerator a with second denominator d. A d plus the first denominator b multiply the second numerator c. b c. Let's try the example. 2 over 5 plus 1 over 7. Okay, I will multiply the two denominators. 5 multiply 7. Then I will take first numerator and multiply it with the second denominator. 2 multiply 7. Okay, second, I will take second numerator 1 and multiply it with the first denominator. 1 multiply 5. 1 multiply 5. So the answer will be 14 plus 5 over 35, which will be 19 over 35. Example 1. Add 3 over 8 plus 1 over 4. The denominator here is not the same. So what we are going to do, as we said, that we will multiply the two denominators together. So 8 multiply 4. Then I will take, yes, exactly, first numerator multiplied by the second denominator and second numerator with the first denominator. 3 multiply 4 plus 1 multiply 8, which will be 12 plus 8 over 32. 12 plus 8 will be 20 over 32. Can I simplify? Yes, of course. 20 and 32. I can simplify them. It will be 5 over 8 divided by 4. Up and down will give us 5 over 8. And note that after finishing the operation, don't forget to simplify the answer if it could be simplified. Part number 2, which was 4 over 12 plus negative 10 over 15. Okay, 4 over 12 will be, I will simplify. Before adding, simplify. Exactly. And 4 divided by 4, it will be 1 over 3, 1/3. And negative 10 over 15, can I simplify? Yes, you can. Let's do it. 10 and 15 divided by 5 will be 2 over 3rd. Now, by negative, don't forget the negative sign. Now, I have the same denominator, so it will be easy. I will keep the same denominator and I will do 1 plus negative 2, and the answer will be negative 1/3. Part number 3, it is 2 over 5 plus 3. Okay, 3 will be 15 over 5. I will try to have same denominator. For that, I will make 3 equal 15 over 5 because I have 5 in the first denominator. So 2 over 5 plus 3. I will remove 3 and put instead of it 15 over 5. So 2 over 5 plus 15 over 5. Now I will keep the same denominator and I will add the denominator. It will be 17 over 5. Part number 4, 3 and 1 over 4 plus negative 2, 1 over 5. Here I have different denominator, so I will try to find the LCM, the low common multiply between them, which will be 20. 4 multiply 5 will give us 20. Then to have the same denominator and make it easy operation. So 3 over 3, 1 over 4, I will change this mixed number into an improper fraction. At first it will give us 13 over 4, and I will do the same with negative 2 and 1/5. I will change the mixed number into improper fraction. Yes, it will be negative 11 over 5. Now I will try to make the same denominator, which will be 20, and 13 multiplied by 5 will give us 65. The same I will do by the negative 11 over 15. 5 multiplied 4 will be 20, and 11 multiplied 4 will be 44. So it will be negative 44 over 20. Now I will add by keeping the same denominator, which will be 20, and in the numerator I will write 65 plus negative 44 will be 21 over 20. 21 over 20, I will change it again into a mixed number, which will be 1 and 1 over 20. Now we have some properties of the addition operation in Q, in the set of rational number. First one is closure property, which means the sum of any two rational numbers will give us a rational numbers, which means that the Q is a closed under addition operation. So any two rational numbers, when I add them together, they will give me another rational number. Second property, commutative property, which means that if I add A plus B, it will be the same if I add B plus A. So A plus B equal B plus A. And note that A and B are rational numbers. Property number 3, associative property, which means if I have A, B, and C, 3 rational number, then if I add A and B together first, then add C, it will be the same if I add the B and the C together, then add A to them. Property number 4, the additive identity. The additive identity is its meaning is that the 0 is the additive identity. If you add 0, it will not change the rational number. So if I add 0 to any rational number, it will not change. And property number 5, additive inverse. The additive inverse means that any irrational number has an additive inverse except the 0. The 0 is its own additive inverse. 0 is its own additive inverse. And the additive inverse for any other rational number, if I have A, so the additive inverse will be negative A. If I have 3 over 5, so the additive inverse will be negative 3 over 5. Now the properties of subtraction operation in Q. Since each rational number has an additive inverse, then the subtraction operation always will be possible in Q. And remember that the set of rational number Q is closed also under the subtraction. That means that any two rational numbers, I subtract them or do the subtraction operation between them, the result will be also a rational number. And the other property is not available in the subtraction because the subtraction operation in Q is not commutative and not associative and has no identity element and has no inverse element. Example number 2. Use the addition properties in Q to find the result of 6 over 35 plus negative 5 over 11 plus 19 over 35 plus 10 over 22. So first, the rational number I can simplify. I will simplify them first. Which one I can simplify? Yes, 10 over 22 by dividing numerator and denominator by 2 will give us 5 over 11. Then I have now 6 over 35 plus negative 5 over 11 plus 19 over 35 plus 5 over 11. Now I can rearrange this rational number to make each two denominator like each other together, and the others will be together, which means that I make the commutative and the associative properties. So 6 over 35 will be with 19 over 35 and negative 5 over 11 with plus or adding to 5 over 11. Now negative 5 over 11 plus 5 over 11 will be 0, plus 6 plus 19 will be 25 over 35. So can I simplify 25 over 35? Yes, it will be divided by 5, will be 5 over 7. Example number 3. Find the result of each of the following in the simplest form. First one, it's subtraction. 5 over 8 minus 3 over 8. So I will make 5 over 8 plus negative 3 over 8. By this way it will be easy, and I didn't change anything. I just make plus negative will be negative. Okay. The denominator is the same, so I will keep it as it is. 5 minus 3 will be 2 over 8. Can I simplify? Yes. Divided by 2 will be 1/4. Next part, 3 over 4 minus 5 over 6. Different denominator. Can I simplify any? No, I cannot. So I will try to make the denominator the same. So 4 multiply 3 will be 12. This is the LCM. And 6 multiply 2 will give us 12 in both sides in the denominator. So 3 multiply 3 over 4 multiply 3 will be 9 over 12, and this will change into negative 10 over 15, and the answer will be negative 1 over 12. Part number 3, 5 over 7 negative 1. Okay, negative 1 means 7 over 7. So I will make the 1 7 over 7 to make the denominator the same. 5 over 7 plus negative 7 over 7. Now 7 in the denominator will be, and 5 negative 7 give us negative 2 over 7. Last example, negative 2 over 5, negative 3 over 5. Same denominator, so it will be negative 5 over 5, which will be 5 over 5, 1, and negative, I will keep it as it is. Complete each of the following. 1. The additive identity elements in Q is. We said before that the additive identity is 0. Excellent. The additive inverse of number 5 over 8. What is the additive inverse? Yes, I will change the sign. Will be negative 5 over 8. It will be negative 5 over 8. The additive inverse of 2 over 7 power 0 will be 1. Anything power 0 will be equal to 1. Any number, any integers, any rational number, power 0 will be 1. The additive inverse of negative 4 over 5. Again, the additive inverse, I will change the sign only from positive to negative and from negative to positive. So the additive inverse of negative 4 over 5 will be 4 over 5. Part number 5, the additive inverse of number 0. We said that 0 is the additive inverse of itself. 0 is its own additive inverse. So the answer will be 0. Part number 6, the additive inverse of negative 0.5. Again, we will change the sign only, so it will be 0.5. Thank you.